Hello everyone, welcome to the another session. In this session, I'm going to discuss about the introduction to the optical fibers. If this topic is given in your syllabus, definitely you should think about why optical fibers as given as one topic in our syllabus. If you think in that direction, definitely you will get informative answers related to that particular topic. First thing, in this video, I'm going to frame the questions related to that particular topic. Why he given as topic in our syllabus? What is the meaning of optical fiber? Where we will use optical fiber? What is the principle involved in working of optical fiber? How the data is transmitted through the optical fiber? What kind of data it can able to pass? What is the meaning of light signal transmission through the optical fiber? That it means that it doesn't transmit the audio or video signals through the optical fibers? Or is there any classification in the optical fiber? Is there any losses present in the optical fiber? How the signal can transmit through the optical fiber? And what are the applications, real-time applications of the optical fibers? If you question yourself related to the title like this, definitely you will get knowledge related to that particular topic. Coming to this, optical fiber is a communication device or the transmission device which can transmit the data from one place to the another place with minimal losses or with lower losses. Before going to the particular topic like optical fiber, in our school days, our age like 7 or 8 or 9 years time, we used to play with matchboxes or any other kind of boxes to communicate one person to the another person, like hello, hello, or hello, like this. So at that moment, we'll tie a thread in between the two matchboxes, like 5 meters, or 10 meters, or 15 meters. We may feel that there is a possibility to communicate the signals like a voice signals from one place to the another place. It's like a game. At that moment, it's like a game. And some cases, we used to speak through pipe in case of water pipes or the channel pipe, or at any moment like a cylindrical pipe like a 10 meters or the 15 meters or 20-meter long. We used to say like hello in from one side, and another person is hearing or not will check by the other person. So here the voice signals can transmit from one place to another place using via medium like air media. If you are able to control the signal transmission in multi-direction, so there is a possibility to transmit the voice signal or pass the voice signal from one place to the another place. This is our motto at that moment. The same, obviously, light point of view. In case of light point of view, if you are able to pass the signal from one place to the another place without loss, then obviously it will be useful for the communication purpose, because obviously light velocity is more compared to the sound velocity. If you are able to restrict the losses, that will be used to send the signals from one place to the another place within short time or the short duration, because light velocity is 3 into 10 power 8 meter per second. But the question is how we can minimize the losses once the light is passing from one place to the another place. When we are thinking in the direction, Definitely we should know or we should think about the basics related to the light. Coming to the light basics. Light is passed like a rectilinear propagation, like a straight lines. Or light is passing from one medium to the another medium, reflection, refraction takes place. If the ray is moving from the rarer to the denser, obviously ray is for example, ray moves towards the normal because the velocity is decreases in the denser medium. Denser or rarer is decided by the refractive index. Here the refractive index is nothing but light velocity in air by light velocity in the medium. If the refractive index is more, means the light velocity in the medium is decreases. Here the optically denser, optically rarer means refractive index is high and low. That only the difference. And coming to the, if it is in the same medium, if it is same medium, when it is reached to the boundary, reflection takes place. If it is transmitted to the other medium, refraction takes place. And we should think about the loss of reflection and the refraction. We also know the formula like Snell's law, mu equals to sin I by sin r. In the process of discussion related to the reflection refraction, we observe one more phenomena, that is the total internal reflection and the critical angle conditions. If the ray is moving from the denser to the rarer, please note this point, the ray should always pass from the denser to the rarer. N is more in the first medium compared to the second. That's what it called as denser, and that is the rarer. The light ray is moving from the denser to the rarer. That angle of incidence, the angle, the ray makes angle with the normal. If it is either equal or greater than the critical angle, the ray gets the total internal reflection. The ray won't move towards the other media or the rarer media. The ray totally reflect back into the same media. That is, the ray is within the medium only. It is not transmitting to the other medium. That means that whatever the signal we are sending, that signal travel in a particular path and it reflect back into the same medium. If I able to create the downside also again internal reflection, so in between the two parallel chambers, there is a possibility to get the multiple reflections. At the same time, it is traveling from the one place to the another place. So if you able to create this atmosphere in transmitting the signal from one place to the another place, then obviously that will be useful to send the signals from one place to the another place, whether it is meters, or kilometers, or thousands of kilometers. There is no issue because we are obtaining the every time total internal reflection takes place. So that is the principle involved in the construction of optical fiber to transmit the signal from one place of the optical fiber to the other end of the optical fiber. So finally, the principle involved in the construction of the optical fiber is total internal reflection. But what about the construction? Optical fiber is like a cylindrical tubes. Just we discussed that light should travel from the denser to the rarer. Then obviously two media should be present. So optical fiber consists the two major components, like two major parts, and surrounded by the protective layer. These two parts are generally called as core and cladding. These are two general parts are called as core and cladding. Core is take it as the central part. So don't think this much size is their optical fiber, very micrometer thickness. We can't say the exact hole. Just to represent the core and cladding, I just taken the like a thick circular shape tape. Here inner part is take it as the core and outer part is take it as the cladding. There is a protective layer like outer jacket to protect the optical fiber from the atmospheric condition like temperature, pressure, etc. But inner part and outer part is called as like a core and cladding. These two are manufactured by using either glass or plastic. Either glass or plastic. Inner part is act like a denser media and its refractive index is N1, and outer part is take it as the N2. It act like a rarer media. N1 and N2 values are not that much different. It's very minimal change in between the core and cladding refractive index. If we maintain the more difference between the N1 and N2, that will give the another issue like intermodal dispersions. To eliminate all kind of issues, the N1 and N2 refractive index of the core and cladding is almost equal. So once the ray is launched from the source, like it is from A to core part, the central part, and at the boundary between the core and cladding, like inner part and outer part, it gets the total internal reflection. Then it will give the multiple reflections, and it is useful to send the signals from one end to the another end. This is about the principle and construction of optical fiber. There is a small recap about this video. Here we are discussing about the principle and construction of the optical fiber. In case of optical fiber, light signals can transmit from one place to the another place by using the total internal reflection. According to the total internal reflection, the light should travel from the denser to the rarer. So in the construction of optical fiber, we should consider the one media is the denser media, another is the rarer media. The ray should travel from the denser to the rarer. That means the ray is traveling from the core to cladding. At the boundary between the core and cladding, it gets the total internal reflection. So in this way, the ray signals can transmit from one end to the another end. The component, that means the parts related to the optical fiber is the core, cladding, outer jacket. Core is like a central part, which is like a transmitting media from one place to the another place, and surrounded by the cladding, it is gives like a rarer nature when you compare with the core. And the third one is the protective layer. This protective layer is related to the, it protects the optical fiber from the atmospheric conditions like temperature and pressure or any external issues. Thank you.